Evolution is the change of life over millions of years through the process of natural selection. Evolution is random but is constantly in motion, one strong example being in carnivora, mainly meat-eating mammals. This group branches off into Caeniformia and Feliformia. But where and when did this all start, one might ask? There was not a large number of carnivorous species, and the farther back in time, the fewer there were. One of the first mammals to prey on other animals was called a Dormaleocyon laturi. This insect and small animal-eating creature lived in the beginning of the Eocene period 56 million years ago and was 2 pounds once full grown. This creature most likely climbed trees based on its tarsal bones that have been found along with teeth and ankle bones in Belgium. A phylogenetic analysis showed that the Dormaleocyon is closely related to the Vulpivus and Myiasis, which are also basal carnivora forms, and originated in North America. Some of the North American species must have migrated to Europe when Pangaea was still around, and as Pangaea broke up and the environments altered, the speciation of the Dormaleocyon occurred. Because of the biogeographical change and the creation of the Dormaleocyon, modern carnivora roam the earth today. Many of these modern carnivora have radial sesamoids simply to keep the tendons on the side of the hand from tearing when an animal bends or twists the wrist. Pandas, being exposed to a different environment than other bear species, grew longer radial sesamoids to grasp bamboo, their primary source of food. These appendages also help to climb trees. Speaking of toes, can you believe that the harp seal and the polar bear are related? Although this may seem unrealistic, the Pinnipedia family, of which seals derive from, and the Ursus family, of which bears come from, evolved from the creature called a pugila, a creature that existed 21 to 24 million years ago. These two white organisms still share a similar phenotype in their toes. Two other related creatures are whales and hippopotamuses. These mammals diverge from the Ambulocetus natans, a half-aquatic, half-terrestrial animal found 50 million years ago. This particular ancestor is a good example of how whales became the ocean-dwelling mammals they are today from earth-walking ones they once were. As can be seen, the longer the Ambulocetus lived in the water, the less it needed back legs for walking, and eventually disappeared from the skeletal system, finally appearing like the modern-day whale 40 million years ago. Those of the Ambulocetus that preferred land over sea eventually lost the water-maneuvering tail they once had, becoming the modern hippo around 6 million years ago. Since all carnivora are mammals, and humans share this quality, this is where the two connect about 100 million years ago. A second connection from carnivora to humans is the pelvis. Studies have shown that human cat and dog pelvises all share the homologous bone structure. Genetically speaking, humans and many carnivora are closely related, shown by the long vertical columns of uniform color. Saber-toothed tigers originate from a more feline descent, as do tigers. Scientists know they must have some relation because their anatomies have many homologous structures. Saber-toothed tigers' long canine teeth were very brittle because of their length. It is safe to say that tigers around the world today have shorter teeth because shorter teeth are stronger. The adaptation has resulted in a more effective predator, providing a greater likelihood of successful reproduction. Although evolution is hard to predict, climate change will play a factor, like polar bears being forced south due to melting ice and crossbreeding with brown bears in Canada. Evolution is everywhere and always in progress. This is especially shown in carnivora on genetic, anatomic, fossil, and biogeographic levels. Carnivora have adapted to their environment in a way that they can thrive all around the world today. Thank you for watching.